আজকের এই মাইক্রোপ্রসেসর ল্যাবের সেকেন্ড এক্সপেরিমেন্টটা আমরা দেখব। যেমন আমি যদি স্ক্রিন শেয়ারে যদি যাই পিডিএফটা, গতদিন আমরা এই অংশটা দেখছিলাম এবং সেটার সাথে জাস্ট এই প্রোগ্রামটা আমরা একটু অ্যাপ্লাই করে দেখছিলাম, প্র্যাকটিস করে দেখছিলাম যে কিরকম আসে। তো একই রকম ভাবে আজকে আরো কিছু ছোটখাটো এই এক্সপেরিমেন্ট 2 বলতে গেলে এক্সপেরিমেন্ট 2ই, কারণ হচ্ছে এটা যদিও এক্সপেরিমেন্ট 1 এর একটা পার্ট হিসেবে দেওয়া আছে, বাট অ্যাকচুয়ালি আজকে এক্সপেরিমেন্ট 2, যে গত ক্লাসে আমরা যেগুলা দেখছি বা শিখছি সেটা নিয়ে আজকে আরো একটু আরো ভালো করে মানে দেখবো কি রকম হয়। যেমন আমি জাস্ট এটা যদি একটু কপি করে যদি তোমাদের ওই সফটওয়্যারটা নিয়ে যাই, তো এই সফটওয়্যার এখানে আমরা এটা দেখলাম, এইগুলো জাস্ট একটু ডিলিট করে দেই। তো এই এরকম আমরা এই সফটওয়্যারটাতে দেখতে পাচ্ছি। আগেরটায় আমরা কি করছিলাম, আগেরটায় আমরা যোগ করছিলাম, এখন এখানে জাস্ট বিয়োগটা দেখবো। যে আগের মতোই সবকিছুই আছে, শুধু পার্থক্যটা কি হচ্ছে, এখানে সাব এক্স বিএক্স এক্স কমা বিএক্স এটা দিয়ে বোঝাচ্ছে এক্স ইকুয়াল টু এক্স মাইনাস বিএক্স। ঠিক আছে, এক্স এবং বিএক্স এখানে যে দুইটা রেজিস্টারের ভ্যালু দেওয়া থাকবে, এই দুটাকে বিয়োগ করব, প্রথমটা থেকে দ্বিতীয়টা বিয়োগ করব, বিয়োগ করে যে ভ্যালুটা আসে সেটা আমরা প্রথম যে রেজিস্টারটা আছে সেই রেজিস্টারে স্টোর করব। এখানে কোনো জরুরি না যে সবসময় এ কমা বি হবে, এমন কোনো জরুরি না। বি কমা সি হতে পারে, ডি কমা এ হতে পারে, এমনকি বি কমা এ মানে বিএক্স কমা এক্স হতে পারে। উপরে যদি আমরা যাই, এখানে যে কোনো কম্বিনেশন, এই জায়গায় যত কিছু আছে এটা যে কোনো কম্বিনেশন হতে পারবে। এএইচ কমা বিএল হতে পারে, বিএল কমা ডিএল হতে পারে, ডিএল কমা সিএইচ হতে পারে, যেটা তোমাদের ইচ্ছা, যেটা প্রোগ্রামারের ইচ্ছা সেভাবে ডিজাইন করতে পারে। তো আমরা জাস্ট আপাতত ছোটখাটো এই প্র্যাকটিসটা আরেকবার একটু দেখে নিই। যেমন এখানে আমরা যদি এই ইমুলেট বাটনটা প্রেস করি তখন একটা নতুন উইন্ডো তো স্টার্ট হবে যদি কোনো এরর না থাকে। তো এই স্ক্রিনটা আমরা একটু দিচ্ছি।
স্যার আমার সাথে আরেকজন আছে কিন্তু ইংলিশ কথা বোঝে। তোমালিয়ান যে মহসিন সাইকো ইংলিশ বলে
আছে। ও আচ্ছা আচ্ছা, মহসিন।
Yes, sir.
What is your full name?
Muhsin Abdullah, sir.
Okay, try. I will try to speak in English to make you understand everything.
Okay.
I didn't see that you have come in class. That's why I'm talking in Bangla. Okay. I'm repeating everything from the beginning.
Okay, sir.
I want to ask all of you that have you understood this? Have you understood this register diagram of 8086 microprocessor? Such that in 8086 microprocessor there are 4 general purpose registers: AX, BX, CX, and DX. Each of these registers are divided in 2 parts: AH, AL, BH, BL, CH, CL, and DH, DL. Actually, they are not separate registers. These registers are the part of DX register. where when we want to use a 16-bit data, 16-bit data, then we will use AX register or BX or CX or DX. But we can also use 8-bit data if we need. For that purpose, we can split the main register AX, BX, CX, DX into two parts. One is called the A higher and another is called the A lower. Both are 8-bit registers, and in combine they both are 16-bit registers. They become 16-bit register. So it's not necessary that we have to use always 16-bit or we have to use 8-bit register. We can use either a 16-bit or 8-bit according to our program requirement. And these are the special purpose registers. These about 10, 2, 6, 9. These 9 registers are special purpose registers, and we don't need to work with these registers in our lab. You may study these in your theory class, and I think that is enough. For we will focus, as this is the lab class, so we will focus on the lab experiments which we will do with only these 4 general registers or 8 small general registers. So this is the main concept. This is the main memory element in the 8086 register, 8086 microprocessor. Now I'm just reviewing the first class to make you understand, as the first experiment was in Bangla. So I am just reviewing the first class in English so that everyone will understand in the class. To make this work, we need to use EMU 8086 simulator or emulator, sorry.
স্যার আমি কিন্তু শুনতেছি না স্যার
You are not listening? You can't hear? Saidul?
Yes.
এখন শোনা যাচ্ছে স্যার এই মাত্র শুনতেছি স্যার
Okay, this class lecture is being recorded, so if you don't understand, you will if you don't listen, then you can listen later in the video. Acha. Now, are you seeing this screen? তোমরা কি কেউ স্ক্রিনটা দেখতে পাচ্ছ? Hello.
Yes, sir.
Do you see the screen?
Yes, sir. Yes.
Okay. Maybe there are some I didn't share the screen, that's why you may not see the screen. I'm just reviewing again that in 808 this is the microprocessor and interfacing lab course, and this I'm reviewing the experiment 1 for everyone in the class. So this is the 8086 registers. There are 4 general purpose registers. 4 general purpose registers: AX, BX, CX, and DX. And each of these registers are divided into 2 smaller registers of 8-bit, equally divided 8-bit. The yellow registers, which are marked here, AX, BX, CX, DX, are 16-bit register. And AH, AL, these are both of them are 8-bit registers, and they both combine the AX register. They AH and AL actually are the part of AX register, and we may use any of these in our lab experiments, in our program to code. Here, 9 special purpose registers are given, and we will focus on only on the um, general purpose registers. We don't as we will not work with these special purpose registers in the lab experiments, so we will just focus on these. You may study the special purpose registers in your theory classes. Okay. um, and here we see the parity bit parity register. Actually, parity this is also the focus. This will be also focused in your theory class, so I will not discuss it here. You will do this in your theory class. So one thing I want to ask you everything, that one thing I want to ask all of you, that what is register? Can anyone explain what is register? Mohsin, do you understand what is register?
Yes, sir. What is register?
You don't understand, or you don't know? Rabbi Hussain,
Yes, sir.
Sir, I don't know clearly what is register.
Sheikh Said, okay. I have discussed this here last class. I'm just reviewing it in English to understand to everyone. What is a register? For example, see, there is a this. At first, I am um, drawing the register. Then you will understand. Here we are seeing 8-bit register. How? Uh, what we are seeing here, this is a register with 8 blocks. Each of these blocks are called flip-flop. Flip-flop means you can store only one bit of data, only one bit, either 1 or 0 in each of these blocks. So this is the smallest this area, or this block, or this cell, we can say. This is the smallest unit of memory in computer system or in digital circuits, which can hold only one bit of data, either 1 or 0. And here we are seeing there are eight blocks. And when we join the multiple flip-flops, when we join the multiple flip-flops, then we can create a register. Register is a collection of flip-flops or more than one flip-flop to store binary data. Binary means 1-0 data. As here, as you are seeing here that there are 8 blocks. So this means this is a 8-bit register. 8-bit register means you can store 8-bit data. For example, if I can say 10111001. For example, just we want to say that this will for just this will store this register can store one of these combinations. There are so many combinations of 1 and 0. So this is one of the combination that this we can say that this can store like this here. Okay. This can store such kind of data. This is one of the example. So this is a register which can store binary data. Now we are coming back to our PDF or lecture sheet, which says this is an register with 16-bit data, or as AX is 16-bit, that means it can hold, as AX register is 16, so it can hold a 16-bit data, or it has 16 blocks like this. But AH and AL, AH and AL can hold 8-bit data. Okay. Now, does anyone have any question on regarding this topic or what I have explained till now? কারো কি কোনো কোয়েশ্চেন আছে এই এতটুকু যতটুকু আমি বললাম সেটা পর্যন্ত?
No, sir.
Mohsin, did you get it? What is register?
Yes, now, sir.
Okay. Now we are going to our next step. Here we are seeing a short assembly language programming code. In 8086 you have, sorry, 8086 microprocessor, assembly language coding is used. Assembly language means it's not too much high language and also not the binary language. Binary language or machine language means it is not in it is not encoded in 0 1. We can use English letters to prepare the codes, but this is not like a C programming, Java programming. This in where which is called actually high level language programming, but assembly language is in between the machine language and high level language, or we can say just like it is the medium level language, we can say, though it is not fully medium. But for understanding we can say that it is in between these. So microprocessor and also another device which is called microcontroller. These are can be programmed in assembly language. And 8086 was a very old microprocessor. Do you know in which year 8086 microprocessor came? Does anyone know in which when 8086 processor was designed? Or
No, sir.
I'm showing you one thing. wait for some minutes. Where it is? I'm showing you 8086 microprocessor here. That 8086 microprocessor was introduced in about uh, 1976 and 1978. 1976, 1978. It came in that time. So, and we can also see this, the 8086 uh, 8086 microprocessor in design. You may have learned this in your theory class, or in colorful, if we want to say. You may have learned this in your theory class. Also, this is the pin diagram. Uh, it's a 40 pin IC, 40 pin microprocessor, which you can see there. These are the uh, denominations of in which what pin can do, what each pin can do. So and also this is the um, 8086 emulator available in your this is the 8086 emulator available in your um, lab, available in the Prime University lab. We if we can do these lab on physically, we can, if then we can see these device, these micro, and but also we can do the microprocessor lab in online by using the software, as most of the lab um, of this course, lab course, is done with a processor. So now we are going to show all of you the software. In last class, I have shown how to install the microprocessor lab software or emulator, that is called EMU8086. If we go back, if we go back to the, so we can see that EMU8086 emulator software we will use to do our experiments. So if we can have the laptop or desktop PC, any kind of PC, then it will be easier for everyone to practice this course. So before going to our lab codes, I want to ask every one of you that does every one of you have any kind of any kind of PC, such as laptop or desktop?
আমার নাই স্যার শেখ সাইদুল
Yes, I
মোবাইলে
know
ক্লাস করে
you don't have it. Mohsin, do you have laptop or desktop?
Yes, I have laptop.
Okay, that's good. And sorry, Rabbi Hussain, do you have? Rabbi Hussain, can you listen? Okay, maybe there is network problem. So as you have this software, so I have given how to install this software in the last class, so I will not discuss this. You just watch that video, then you can download and install this software on your laptop or desktop. So I just now want to show that how our these experiments work, such that we need to work with assembly language, such that here I just make it copy, so, and I will so here we are seeing the first lines: move ax comma 0004h, then move bx comma 0058. What that means, it means that we have to load this 4 value into AX register. Similarly, we have to load this value into BX register. What H means? H means hexadecimal number. Okay, hexadecimal number, we have to work with hexadecimal numbers only. We cannot leave this H. If you forget to write H, then it will give error. uh, I don't actually, we will test this whether it will give error or not just after some with our experiments. Here we are seeing that these lines meaning is this, which is if this assembly language says we write in this way, it means that AX equal to 0004H. Move BX means move BX equal to this. And the third line, add AX comma BX. Why add AX comma BX? Because in our problem or question, we have to find the program. We have to write the program to addition of two hexadecimal numbers. We have to add two hexadecimal numbers, and we need to write the assembly language for this. That's why we are adding here two numbers, AX and BX. So what these assembly language means, or assembly language instruction means, is we have to add the first register and second register, AX and BX, which is done here, AX plus BX. Then we have to store that result of that addition into the first register, which is here AX. That means the overall meaning of this instruction is AX equal to AX plus BX, which we can see that 4 plus 5 equal to 9. Okay, so but you may have asked why we are writing 0009H. We can write only 9H. I am writing this 009H because our register is 16-bit register, and it can hold 16-bit data, or if you understand the hexadecimal numbers, then this 0009 actually are 16-bit binary data. If you don't understand how this hexadecimal becomes binary, then I will explain 1 minute. Just hold for some seconds. Now see this picture. Here we are seeing that the conversion between the four types of numbers: decimal numbers, binary, octal, and hexadecimal. And here we see the 9 means this 9, hexadecimal 9 means in binary 1001. Similarly, 0 means four zeros. All of these are actually here four-bit numbers, 4-bit binary numbers. And hexadecimal numbers are 0 to 9, and then after A to F, capital A to F or small a to F, that doesn't matter. And in decimal numbers, if you convert this hexadecimal into decimal numbers, then we can see these numbers are 0 to 15. Okay, binary, these are 0 0 0 0 0 0 0 1 2 1 1 1 1. These are the patterns or combinations. and I'm skipping the octal numbers as we may not work with octal numbers. We just need to work on decimal, binary, and hexadecimal numbers. So this is the list. This is the chart. This is the chart where uh, you can understand how these hexadecimal numbers become these numbers, these binary numbers. Do you everyone understand this, or these? I know that these number conversions have been studied. You have studied in your computer fundamentals course or digital electronics course. I just review this uh, number system so that you may study properly. Is there any question in this number system? Any of you? Okay, now then we are going back to our code. Now, how to use this with the emulator. At first, we start the software. Uh, I have already installed it, and if you don't understand how to install this software, please watch the previous lecture video. Then you will understand. If you don't get how to install it again, then ask me in the group. Then I will show you, or I will tell you in the next class. So when we open the software, it will say like this, that EMU8086, EMU8086, and we need to select the new file or new program and select the empty workspace. It is already selected, and just do the click OK. So does everyone watch this? I think everyone is seeing this screen. So I'm just pasting the code here, which I have copied before earlier. So we are seeing this is the same code as the as this. The same code. I just copy this code into the emulator software. Now now we now we want to run this program, or we want to execute this program to get the result of this program, which should be ax plus bx equal to 9. So, and which will be stored in ax register. So how we can do that? We need to do this. We need to click on the or press on the emulate button. When we do this, as we are seeing, just wait. As you all are seeing that another window is opened. Okay, another window is opened, and uh, when we when we click on the emulator button, this screen will open, and here in this uh, right side we are seeing our code 00048, move bx, add x, bx, halt, and there are some about 12 to 15 NOP. NOP means no operation. We don't write this no operation, but these no operation or no instructions are added automatically by this emulator. So when we click on the first instruction, then we see this is this is highlighted in green color, and then here we see the machine codes. I'm not yet make you understand what is machine code. I will make it clear in the next classes. Hopefully from fourth experiment or third experiment, I will make you understand what is machine code. Just for now, see the machine code. You don't need to memorize any of this. If when we click on the move bx second instruction, then we see that there are another three which are highlighted and in maybe yellow, sorry, not yellow, yellow and orange mixed color. There are three another machine codes. When we select the add ax bx, then see there are two machine codes, 03c3, 03c3. Just watch this. For the first one, B80400. Second instruction, BB0500. Add XBX 03C3 and halt means F4. And we don't need to work with NOP, just we are stopping here. So okay, we are seeing here this. Um, these are the main code we write in the emulator or editor of the emulator, and we are seeing this result, sorry, not result, machine code. Now we want to find the results. How we can find the result? Here in this section you see the all the registers, general and special purpose registers, all the registers I have told you in the beginning of the class that this is the AX register. All of them are 0. AX, BX, CX, DX, all of them are 0 here. So if we want to know the result of this instruction or this program, then you have to do this. You have to click on this run button, which says make automatically. Okay, when we run this, then we see the emulator is halted, which means program executes completely, and we see here that before execution of the program AX is 0 0, but now AX becomes 9, and also BX was also 0 and it becomes 5, which means uh, we are seeing that this is the result. Bx equal to 0005 and ax equal to 0009, and as the result ax is 09 and bx is 05. At first the value of ax is 04, then the second line bx is this, then on the third line ax a value of ax is changed from 4 to 9, as the instruction says to add these two numbers or two registers and store it in the first register. That's why a value of ax is changed. Now another thing we need to I want to show you that how each and every of these instructions are working. Just I'm reloading the whole program, and when we reload that, you can see that all these registers are now 0. Okay, all these registers are now 0. Now if we want to see individually what what instructions are doing, how we can understand this? By using this single step. We don't want to run the whole program at once. We want to run run each and every instruction one by one. So when we run this, we will get to understand how these AX and BX registers are changing. Okay, let's watch this. This is the first, and we want to do the single step. When we do, sorry, again, just watch this. Here there is everything is 0. Now I am clicking on the single step button. When we and the first one is executed, and we see that Ax values change from 00 to 04 as stated in the as stated in the code. Then this line is waiting to be executed. If we again do the single step, then this line is also executed and bx value is changed from 00 to 05. Now add the third line is add x comma bx. Then what should be done? These 04 value should be these 04 x equal to 04 value should be changed from 04 to 09. How? Just see this. If you press the single step button, you can see that value is changed here. And finally halt. Halt means stop, to end the program. If we again do the single step, then we will see the emulator is halted or stopped. So this is the main process of the whole one of the smallest programs you have learned, one of the smallest program to add two hexadecimal numbers. Okay. Does anyone have any question regarding till now what I have said?
Sir.
Saidul,
বুঝতে পারছেন স্যার
Rabbi, are you listening? Then Mohsin, have you understood what I
Yes,
have
sir.
said? Do you have any question?
No, sir.
Okay, then we just till now we have review our first lecture for every one of you. Now we are going to our today's experiment 2. Though here we are though I have mentioned it the part of experiment 1, but actually we will do this for experiment 2. And one thing I want to mention, you don't need to submit any kind of lab report. I will just give you some example class test or class work, and you just need to practice either on your laptop. If you don't have laptop, you can also work with in your scripts khata. Okay. You can work on your plain paper, write down the codes and work on with it. Now we just
একদম কিছুর উপরে নিবেন স্যার মাইক্রোপ্রসেসরের থিওরি দিতে কিছু নেবেন নাকি স্যার
lab no theory.
ল্যাব তো স্যার আমরা স্যার কম্পিউটার নাই স্যার মোবাইলে দেখবো কি
I will teach you in that way that if you don't have the laptop or desktop, you can do your experiments. This is I will teach that in that way. It would be better if you have laptop or desktop, but if you don't have it, it will be not problem. I will take care of it. I will think of it. Consider this for everyone. Okay, now we are going to our first experiment in the experiment 2. What it is saying? It is saying that subtraction of two hexadecimal numbers. We have to subtract or minus actually two hexadecimal numbers. For that, for example, ax equal to 8, bx equal to 5, ax equal to 8, bx equal to 5, and subtract x comma bx, which means 8 minus 5 equal to 3. So just practice it. that we are seeing here, we can give here 8, here 3, and here is SUB. Now, something you need to understand that maybe if you have typed wrongly, such that you have forgot X, then what will happen when you do the emulate? It will give you an error. I'm showing you the error. Can you watch the screen that which is showing there are errors?
Yes, sir. That was sir.
Okay. Here we are seeing that there are probably two error has been done. So we need to correct. We need to correct here such that X. Similarly, if we forget the comma, then if we emulate, it will also show problem that there is no sufficient parameters or operands. So we have to write this again. If we do this, for example, or forgot this, then what it will be, it will say that it is illegal instructions or instruction. So we have to write this. But if you forget this halt, there will be no problem. Okay, there will be no problem in this case. The program will start very beautifully in here. So halt is not mandatory, but we will write this in order to make it beautiful. Similarly, if we type an extra b, for example, so it will say that there is wrong, there is illegal instruction. Okay, then we are correcting it. Now, another thing, if you forget to write H, what you are saying that this number is color is changed. If we do the emulate, oh, actually it is not showing any problem. It automatically converts the number in hexadecimal. For example, if we see that whether we give the H or not in the software or in the emulator, the program will not find any error or see any error. It will just think that the number is number you have right. No, where is it goes? So if you don't write the H here, it will not be any problem. It will be converted automatically in hexadecimal. Just write another number. For example, I want to write A8 000 A8 for this. Just try to make it. When you see that AX8 here we are seeing an error, but if you write it in 5 words, I think it will not be any problem. Oh, another and again problem. 8, of course it's no problem. So it is better to give the H word or H letter, sorry, H letter, so that it will the emulator will understand that this is a number, and you will also understand, the programmer will also understand that it is a number. Now we just test this second experiment, or sorry, the first experiment of a second, first part of the second experiment, emulate what it will give. It will give us this, and the result should be 8 minus 3 equal to 5. So here see that here everything is 0. Now if we run this, then the x should be 8 minus 3 equal to 5. Here we are seeing that ax is equal to 5 and bx equal to 3. And if we do the whole thing from a single step, one by one, then we are seeing at first ax is 8, then bx is 3, then ax equal to 8 minus 3 is equal to 5. Finally, the program emulator is halted. So, oh, actually, I have given here 5. That's same. That's the same thing. Another example is multiplication of two hexadecimal numbers. We will see another two examples. Multiplication মানে গুণ করা, two hexadecimal numbers multiplication. What are the numbers? 4 and 5, and then what we will see, what we will write, only just mulbx, small bx, which means we don't have to write the first register. If we see the explanation or meaning of this instruction, then we can see that this instruction means multiply ax and bx and store it in ax. This is the common thing. I am explaining it here, that mulax equal to ax equal to ax dot ax. B, C, D. These what you are seeing for multiplication, these are the rules. You have to make it understand. We only these 4 multiplications can be done, and ax equal to x into ax. If we write this, multiply bx means x equal to x into bx. All of them are in all of these, the ax is common, this part is common, just the what we are writing here, it is changing here, and the result is stored in the AX register, which is also known as accumulator, which I have forgot to tell. The name of this register, AX register, is called accumulator, and this is a very important register in the general purpose registers. That is why this AX register is doing here, storing the results. So if we go back to our coding, then we are seeing if the 4 and 5. So one thing I need to add here, that this result is not actually stored in AX only. This is also stored in DX. All of these results are stored in DX and AX. Which part? The AX actually, I'm showing you in some example, like another text. If we give, for example, if we want to 1, 2, 3 multiplied by 1, 2, 5, 6, for example, if we multiplied these numbers, I'm showing you in calculator. and selecting the hex number. Actually we have to work with hexadecimal. So what are the numbers I have said? I have given 1223 and 1256. So but at first we need to select the hex. 1223 multiply 1256. When we multiply this, after this we are seeing 14C8DC2. This is a huge number, and AX register can hold only the last 4 digits. It cannot hold the first uh, first 3 digits in hexadecimal. So to hold this to hold this answer, I'm showing you the answer by copying it. When we do this calculation, then we will see. Sorry, I just tried to not X here, it should be here. There are two different numbers. Let AX equal to this, BX equal to this. When we multiply MULBX, it will give AX equal to 8DC2, 8DC2H, comma, DX equal to DX equal to 014CH. Okay, in this way the multiply works. All these results, the first lower the result is actually the multiplication of these two numbers are one. If we multiply here 1256 equal to actually 14C8DC2, these numbers become actually a huge number, and that's why the first one goes to the D register and the last one goes to the A register. You need to remember these to understand this, to work with these features of microcontroller, microprocessor. So now we just do some simple 4 and 5, and if we do MULBX, then if we emulate, we are seeing that after emulation what we should get 4 into 5 means, if you do the calculation just to see the result at first, in result here, if you run this program, then we can see that here result is 14, but clearly you can think of it that 4 into 5 is 20, and how it becomes 14, because this is hexadecimal number, it is not decimal calculation. If we see the calculator, if you see this calculation in calculator mode, that selecting this hexadecimal, then 4 multiply 5, if we give If we give this 4 and multiply 5, then we can see result is 14. But in decimal, we are seeing that decimal result is 20, but hexadecimal result is 14. So we are working here with decimal numbers. Sorry, we are working with here, working here with the decimal numbers, the hexadecimal numbers. That's why the result is in hexadecimal, which is 14. If you were to here with the decimal numbers, or it can show the decimal numbers, then it should be 20. And today's last experiment, I'm shortly uh, showing you. Sorry, last part of our experiment today, which is division of two hexadecimal numbers. Similarly, we can see just 19, first number is 19, second number is 5, and the DIV also follows the same pattern of multiplication, which means if we see here that multiply and here we just give, then the result, the same pattern will be find that ax is common, and the whatever we are giving here, it will be divided from the ax register, and the result will be stored in the ax register. And the same pattern, if the number becomes very large, then the first 16 sorry for, the first 16 bits or 4 digits of a hexadecimal will be go to dx register, just like here, and the later 8 digits will 16 digits or 4 bits, sorry, I said wrong, the 16 bits or 4 digits the later part will be go to the first ax register. So just do this experiment again, the last experiment of today's, such that here we are giving 19, and here giving me 5, and here div. Why 19 by 5? You may ask, 19 by 5 uh, is a fraction number. Just watch first, then we will understand that this gives, when we run this program div then we can see the result is 5, 5, 5. Why or how? When we see the PDF, here we see the result is 19 and it is 5, and answer is 5. Actually, there it is not 19 decimal, it is 19 hexadecimal, which means 25 in decimal. If you see the calculator, that 19 in hexadecimal is equal to 25 in decimal. That's why when we divide it by 5, it becomes 5. Okay, if you watch this closely, then you will understand that 19 in hexadecimal is actually 25 in decimal. That's why when we divide it by 5, 25 by 5 or 19 by 5 is equal to 5. So this is the these are the experiments we have to do today. We will see some more experiments, which I will give it name as experiment 3 from next class. So Does anyone of you have any question till now of what we have learned or see?
No, sir.
Okay, then just I'm closing this and just to take your attendance.
স্যার অ্যাটেন্ডেন্স দিতে হবে নাকি এখন এই জায়গার মধ্যে নাকি আপনি
No, you don't.
আপনার কাছে পৌঁছে দেবে?
No, you don't need to say anything. I will do it by myself. Just I'm seeing your names in the chat box. Okay. Mohsin, have you any question?
স্যার আমার যে নাম স্যার ওইটা তো আমার জুম অ্যাপের মধ্যে নাম দেওয়া আছে স্যার ওই নামে তো চলবে না স্যার?
হ্যাঁ 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 সেটাই হবে।
আচ্ছা স্যার, থ্যাংক ইউ।
ওকে, যদি কারো কোনো কোয়েশ্চেন থেকে করতে পারো, না হলে আজকে ক্লাসটা এখানে শেষ করলাম।
আচ্ছা স্যার, জি স্যার, আসসালামু
Okay,
আলাইকুম।
thank you everyone for this class.
থ্যাংক ইউ স্যার।